Hey guys, I made this little video showing my Eggbert graph using LoggerPro. I found this way of presenting easier for you to understand. I'll draw in labels and explain things as we go. I then redirect you to my PowerPoint presentation to show you more of my understanding of the three forces. Alright, let's go. So here's my Eggbert freefall graph. And this is where I drop the egg at 0 meters per second. And this is where my egg landed. As you can see here, I had no terminal velocity, which actually makes sense considering I didn't have a parachute. The parachute would have acted as like a drag force against gravity, which explains Newton's third law. For every action, there's an equal and opposite reaction. I chose a curved fit line because all my dots line up almost exactly on it. And here, I chose a linear best fit line to see the closest points where I could get terminal velocity. And you can see here those 3 points are probably the closest thing I had to terminal velocity. So let's head to the math now. As I said, those 3 points are the closest thing I had to terminal velocity. So I took the velocity of the last point of the 3 dots and used that for final velocity. So this whole math part will show you a little of my understanding of F equals ma. So first I did the equation to find acceleration, which is final velocity minus initial velocity divided by time. So I did 9.842 minus 0 divided by 1.371. So I plugged it in my calculator and blah blah blah, and I got 7.179 meters per second squared. Now that I found the acceleration, I have to add the mass of the Eggbert container with the egg inside it to find the force. So the egg weighed about 68.2 grams, and then got the mass of the container, which weighed about 165.15 grams. And the total mass, I forgot units. And the total mass was about 233.35 grams. I converted the grams into kilograms, and this turned it into 0.2335 kilograms. So F equals 0.2235 divided by times 7.179. Sorry, I'm stupid today. I'm tired. Okay, let's do the math here. 0.2335 times 7.179, and we get 1.6752. Oh, whoops! What did I do? We get 1.675. So the answer will be, so the force here that is acting here is 1.675 newtons. That concludes our LoggerPro time. Alright, let's head over to my PowerPoint. Here we go. Full screen now. There we go. Eggbert freefall presentation continued by Sasha and Zaymana B2. So, small joke here. What happens when you tell an egg a joke? It cracks. Buddy. You guys get it. Well, if you guys don't think it's funny, terrible sense of humor. Anyway, where was I? Okay, yep. You guys probably have my understanding. My understanding of F equals ma. Well, I basically just showed it to you guys back in LoggerPro stuff. But basically, acceleration is produced when a force acts on a mass, and the greater the mass, the greater the amount of force needed to accelerate the object. Moving on to inertia man. Well, I applied the law of inertia in my thinking when doing the Eggbert experiment, and because objects that are in motion want to stay in motion unless they are stopped by an external force. In this case, this is the ground. That was the external force. Moving on to Newton's third law. For every action, there is an equal and opposite reaction. Well, in this case, a parachute would have made a great example for this, so I might just use it. Gravity is pulling down on the object, but because of the parachute, there's also air resistance, which makes it an equal and opposite reaction to gravity. Anyways, thanks guys for listening to me today. Bye.